functions are easy to tell if you're looking at a graph. So on number 4, this is the easiest one to determine if it's a function or not. If it is not a function, you can do the vertical line test. If you draw a vertical line anywhere through and it touches more than once, it's not a function. Okay, the rest are from tables and they're not as easy to tell. But in functions, this is what you plug in and this is what it spits out. So this is input, this is output. If you plug in a 3 and it gives you a 1, and you plug in a 3 again and it gives you a 5, this is not a function. No. Every time you plug in 3, it needs to give you the same answer every single time. So number 1, you plug in 100 and it gives you 50. You plug in 200 and it gives you 100. You plug in 300 and it gives you 150. So this one's a yes. And number 3, 1 gives you 2, 2 gives you 4, 3 gives you 6. This one is a yes. So if you plug in a 1 and it gives you a 10, and you plug in 2 and it gives you a 10, you plug in 3 and it gives you a 10, that's okay. They can give you the same answer every time. So, and if you want, you can do a little graph over 1 up 10, that dot's like right here, over 2 up 10, that dot's right here, over 3 up 10. But number 2, if you graph those 2 dots, you've got over 3 up 1, so you got a dot right there, and then you got over 3 up 5, and you cannot have 2 dots on the same number. Okay, piecewise functions. So you've got 2 pieces. So we've got y equals x minus 2, and we've got y equals x plus 3. So if we graph y equals x minus 2, the m and the b, we need where the slope is and where the y-intercept is, the starting point. So m is the number in front of x, right here. In front of x, we've just got 1. So it's going to be 1 over 1. B is the constant. B is the number all by itself. B is negative 2. So that's where we're going to start. On the y-axis, come down 1, 2, negative 2. And then from this, you use your slope to get a bunch more dots. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And here we got all these dots. Okay, your line would go forever, except for we just want a piece of it. So we want this piece right here. We want the piece that exists if x is less than a negative 1. So if x is less than negative 1, so negative 1 right here. Here's negative 1. Okay, anything smaller than negative 1. So just think of this x number line. So here's negative 1. Smaller is this way. So if you're looking at like a one-dimensional, here's the number line, there's 0, negative 1's right here, it's circled, and it is left empty because less than or greater than, they're circled and left empty. Less than or equal to, greater than or equal to, they are circled and filled in. So it would be circled and empty, and anything less than is going to be to the left. So we've got this boundary line right here, this negative 1. Since we're looking in 2 dimensions, here is our line, and it is going to be anything to the left of the line. So I'm going to erase all of this stuff right here. I'm going to put a new dot and leave it empty, and then there we go. Okay, now this next piece, x plus 3, my m is what's in front of x, my m is 1, my b is 3, so b is my first dot, my y-intercept on the y-axis go up 1, 2, 3, I got a dot, and then slope 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, so I've got a line that's going to go through all these dots. Now I just got to figure out what piece I want. I want the piece if x is greater than or equal to negative 1. So it's the same boundary line, this negative 1 right here. I'm going to use that same line. So it's going to start on that line. It's going to be equal to that line. So I'm going to circle and fill in. And it's anything greater than, so it's going to be anything to the right. So I'm going to erase everything on the left side. Okay, now domain and range. Let's talk about domain and range real quick. the domain is how much it covers left to right. Alright, so left to right on this X number line. And this piece looks like it's going to go forever to the left, and this piece is going to go forever to the right. So on my number line, I've got something going forever to the left, but then the black line starts at -1, but it's filled in, and it's going everything to the right. So everything on this number line is going to get covered. So the domain is going to be -infinity all the way to +infinity. Okay, so remember, circled and left unshaded are parentheses. Circled and shaded in are brackets. Okay, my range. The range is how far up and how far down. Alright, so the range, this pink line, it's going to go forever down, and this black line is going to go forever up. So my range is going to go all the way to -infinity. But up and down, I've got this huge gap right here. I've got this gap right here, this window, where I've got some empty space. All this is empty space. There's no graph in this empty space. So the pink line is going to go all the way from -infinity, and it is going to go up right there. That's where it starts, which happens to be, okay, now on the Y number line, it's this one going up and down. Here's 0, here's -1, here's -2. This is -3. That's where my graph starts. So -3. Parenthesis, because -3 is empty. And then my black line, it looks like it starts, its highest point is at 1, 2. So its highest point is at 2, and then it goes, or its lowest point is at 2, and its highest point is to infinity. But 2, because it's circled and shaded in, 2 needs to be a bracket, because that bracket tells me it lands on 2 and it includes 2. Okay, now we got to put this into a picture. So you're going to rent a bike. Here's your prices. Can you graph it? And it's going to fit a special function. Is it piecewise? Is it a step? Is it one of our absolute values? So the type, and then graph it. Don't worry about writing it. Just graph it. I want to see your picture. So time, this is what we're plugging in. And the in is always this x-axis. So this is time, and this is what it's spitting out. So price, this is money. Our time is measuring half hour, so let's go call this 1 hour, call this 2 hours, call this 3 hours, call this 4 hours, etc. And then our money, maybe I can go by fives. So I'll go by 5, 10, 15, 20, 25, maybe not, 35, 45, 65 is going to be at the very top. Alright, so now, to rent a bike from 0 to a half hour, they're going to make you pay $5. This is going to be a step function from 0 to a half hour on the time. So 0 to a half hour is right here. So between these two intervals, and $5. So 0 to 30 minutes. Now, they're not going to make you pay $5 at 0. They're going to make you pay anything after 0 and up to 30 minutes, including 30 minutes. So 30 minutes is filled in. Okay, the next interval is between 30 minutes and 2 hours. So between 30 minutes and 2 hours is $25. So 30 minutes and 2 hours, here's 25, that's the start, 30 minutes, here's the end, 2 hours right there. Okay, now at a half hour, they're not charging you 25, they're charging you 5. But anything after a half hour, they're charging you 25, 25, 25, all the way up till 2 hours, including 2 hours, they're going to charge $25. The next interval is between 2 and 4 hours. So if you want it between 2 and 4 hours, they're going to charge you $40. So you come up here to $40, 2 hours, let's see, 4 hours right here. Anything between's $40, and then 4 hours is $40, but 2 hours is not $40. 2 hours is only $25. And then the last 4 hours to 24 is going to be 65. So 65, 24, stop, end. 65 right here. Okay, this is an awesome question. Let's do the domain and range. This is a great question. Domain. Okay, the domain is your inputs, all of your inputs. So what's something I can plug in? Can I plug in 60 seconds? Can I plug in 1,000 seconds? Can I plug in 5.5 hours? What are some values I can plug in? And my domain is anything from 0, I guess we're in hours, to 24, including 24. So 24's got a bracket, 0 does not. If you put, I don't know, 0, you could argue if it's got a parenthesis or a bracket. You can include 0. I wouldn't mark it wrong either way, because that can be interpreted probably both ways. You could come up with a good argument for both ways. So if you put a parenthesis or bracket around that one, I don't really care. The range, the up and down, what are the different outputs? Is it ever going to spit out 75 cents? Is it ever going to spit out $7? The answer is no. Your range, you've only got 4 elements in your range. And if it's nothing between, we're going to make a list. So our range, I got 5, I got 25, I got 40, and I got 65. Those are the only 4 it's ever going to spit out. And that is it. Okay. Alright. Let's look at a picture. If I give you a picture, you got to match which of these 4 inequalities is going to match this picture. So it used to be, this vertex used to be up here at 0, 0. It looks like it has been 1, 2, slid left 2. So left 2, I'm going to eliminate this, and I'm going to eliminate that, because if it's minus 2, that's moving it right 2. And then it moved down 3. Okay, down 3. Looks like that's down 3, and that's, so now the only thing difference is this guy and this guy. So one of them's right, one of them's wrong. And this is like a y, this f of x. So the y-axis is right here, and it looks like everything is shaded below the graph, so it's going down on the y. Below is less than. Greater than is everything above. So this one's got to be D. Okay, this one, evaluate a function, find f of -1. So -1, here's your function, x squared minus 6 divided by x plus 2. Take a -1 and substitute it in for that x, in for that x, in for that x, and let's see what happens. So if you substitute in for this one, you don't put parentheses. If you do it in the calculator, you're going to miss it, because -1 squared is totally different than -1 squared. -1 squared without the parentheses, all you're squaring is the 1. So it's -1 times 1, which is a -1. But the parentheses say you're going to square the 1 and the negative. So it's a -1 times a -1, which is a positive 1. So that's a trick that's probably going to show up on the test. Because if I have you plug in a -3, you got to square the -2. Okay, so we got -1 squared is positive 1. So we got positive 1 minus 6 times -1. So we got 1, a -6 times -1. We got 1 plus 6. Whoops. -6 times -1 is positive 1. So we got positive 6. 1 plus 6 on top. On bottom, we got -1 plus 2, which is 1. 1 plus 6 is 7. 7 divided by 1 is 7. So we're going to come up with D. identify the range of this. Y is equal to 3 times absolute value of x plus 2. Probably you can just do a quick sketch. So this plus 2, here's my 0, 0. The plus 2 is moving it left 2, dunk dunk, and then the minus 2 is moving it down 2, dunk dunk. The 3 makes it steep, so here we go. So the range is everything up and down. Is the range all real numbers? That's the same thing as negative infinity to positive infinity. It's not all real numbers because the range, the lowest it's going to go is right here. The highest it's going to go is to infinity. And this right here is negative 2. So x, let me show you the difference between this. B is a trick question because x is the x-axis. X is not the range. X-axis is the domain. The range is the y-axis, so it's going to be between C and D. It's because these are y's. So the y is anything greater than or equal to 0. So on the y, here's 0. Anything above 0, or do we want anything above negative 2? And we want D. Anything above negative 2. Okay, the graph of the linear inequality is the region, fill in blank, the graph of y equals 3x minus 1. It's either above, below, on or above, on or below. Here is the plan. You cannot do anything. We need y by itself. So let's get rid of this negative 2. Let's divide by negative 2. You got to divide this side by negative 2. So we're going to have y. And anytime you divide an inequality by a negative, if you divide or times, you got to change the direction. So we got to flip it. Less than or equal to, and 3x divided by a negative 2 and a negative 1 divided by a negative 2. So the big deal is this. We are shading less than, and less than is going to be below. Okay, now so we got two options. We got B and we got D. So here's what I would do. On your calculator, graph this, type this in, y equals 3x minus 1. If you graph y equals 3x minus 1, it's going to be minus 1, then up 3 over 1, up 3 over 1, up 3, so it's kind of a steep line right here. Now, on your calculator, graph this. And remember Caitlin's trick. If you hit, go into your graph and hit plus, so F2, we're going to graph two functions. This one should be there. Hit backspace on the equals, and then you can choose between less than, greater than, less than, or equal to. So if you don't know how to do that, make sure I show you how to do that. Make sure you know how to do that, because you can graph both these. So y is less than or equal to 3x minus 2, and that's plus 1/2. So my 1/2 is my starting point. So 1/2, there's my starting point. And now I'm going to go up 3, left 2, rise over run. So I'm going to go up 3, left 2, up 3, left 2. And I think this is actually a typo, because if I graph it less than, so my line is going to look like this. So I got a choice between a dotted line or a solid line. And because it's equal to, it's got to be a solid line. And then I'm shading everything less than, so that's below. So it's going to be everything below. But here's what this should say. This should be a freaking, and this is a typo, because these two lines are crossing. So is everything shaded above the red line or below the red line? And the answer is, well, you got some above and you got some below. So I want to compare this one. I want it to be y equals 3x divided by negative 2 plus 1/2. I want the lines, the line on the test, it's going to be the same line. Two lines, but they're going to be on top of each other. So this line right here is everything above it or below it, or on or above or on or below. And because it's less than or equal to, it's going to be on or below. So the trick is this: if you divide by a negative, you got to change the direction, or if you times by a negative, change the direction. Okay, this last one. Which one describes that Bob has at least 3 pets? So P is for pets. So at least 3. If you're looking at a line, here's 3. He has at least, so he's got more than 3. So anything bigger than 3. And he does have 3, so it's included. But I guess it would not be this, because this says he could have 3.2 pets and 3.5, and that's not true. So it would look more like this. Here's 0, 1, 2, 3. He'd have a pet at 3, he'd have a pet at 4, he'd have a pet at 5, he'd have a pet at 6, he'd have a pet at 7, 8, dot, dot, dot. But he would have no pets in between 3 and 4, because you can't have 3.2 pets. So your graph would look like this top one. And this top one is an example of discrete. So you have individual dots. And this one, if you have numbers in between, that is continuous. So discrete is just a bunch of dots. Continuous, you can have pets in between 3 and 4. You can have fractions of stuff. So we're going to go with B. The pets are going to be greater than or equal to 3. Okay, write a function. You're going to transform this. You're going to slide it down 3. So down 3 is a minus 3. And you're going left 1. Left 1 in the parentheses, that's a plus 1. So you can do it either a couple ways. You can graph this one real quick. Minus 3, so 0, 0 is where we start. But minus 3 is 3 to the right. 1, 2, 3. And then plus 2 is up 2. Up 2, dunk, dunk. And it's a quadratic, it's a parabola, so it's going to be curvy. Now, if I want to take this down 3, I need to take the vertex down 1, 2, 3, and then 1 unit left. It's going to be like right here, so my new one's going to be right here. So you add these together, my new function is going to be 1 to the left, that's going to be x minus 2 squared, and add these together, that's a minus 1. So if I go minus 2, that's 2 to the right, and down 1, that's where it should be. Okay, how about this one? Reflect it over the x-axis. That is if you put a negative out in front. Negative flips it over. Slide it 4 units right and up 2 units. So the original x minus 3 is going to be 3 to the right. 1, 2, 3 right here. And then it's going to be parabola. Okay, now I want to just flip it, and then I want to slide it 4 units to the right. So if I flip it upside down and go 4 more units to the right, 1, 2, 3, 4, it's going to end up right here, and it's going to look like this. So this is going to be y equals, or function notation, f of x equals a negative out front. X, I want to go all the way to minus 7 squared. Okay. How about this one? Delivery truck can up to 1,200 pounds of cargo. You're asked to deliver tables and chairs to a wedding. We did a problem like this. Each table weighs 200 pounds and each chair weighs 60 pounds. Write a function to model this scenario and then graph it. Okay, remember, the weight's got to max out at 1,200. So this one's tables. It doesn't really matter which one is the input and which one is the output. This is chairs. But I do want to know, if I take 0 tables, how many chairs? And I want to know if I take, oh, I guess they've got it labeled, so I need to match what they're labeling. This is the X, which is always the in. So I need to switch my tables and chairs. This is my Y, which is always my out. So I guess I should look at the problem. And I'm going to have to change it to match their graph. So here we go. Chairs is X. And tables is Y. So 0 chairs. If I do 0 chairs, how many tables can I do? So the tables are 200, so I'm going to do 1200, which is the total, divided by 200, and that is 6 tables. That's all I can do is 6. If I do 0 tables and 6 chairs, no, 0 tables, how many chairs? 1200 divided by 60, and that's going to be 1200 divided by 60 is going to be 20. So 20 chairs, 0 tables, or 0 chairs, 6 tables. Let's dot them. 0, 20. Not 0, 20, 0, 6. So 0, left, right, don't go anywhere, but go up 6. Dot and circled, because you do include the 6 tables. Go right 20 and up 0, so go right 20, up 0. Now connect them, but because it's inequality, you got 2 options. You got connecting them with a dotted line, or you connect them with the solid line. Gosh dang, this is an awesome question, because I think my circles cannot be shaded in. I think these circles got to be empty. Let me tell you why. So I think they got to be empty circles because it says I can do up to 1,200 pounds. That if it said this, up to and including 1,200 pounds, then you could include 1,200. But my question is, can this truck do 1,200, or can it only do 1199.99999? Can it do 1,200? So that's the question. If it can do 1,200, then these dots are solid and my line is solid. So I need to be real specific. Up to and including, or up to and not including. Because I got to be real clear on if you're going to include the 1,200 or not. So let's say we're not including it. If we are not including it, I need to have empty dot and empty dot. So I cannot take 6 tables. I could only take 5 tables, and I cannot take 20 chairs because 20 chairs is 1,200. I'd have to take 19 chairs. So I got a little carried away again. This is dotted line, because you cannot take anything on that line. You can only take everything underneath it. So I could take 8 chairs and 3 tables. I could take 12 chairs and 2 tables. Okay, last one. You need to substitute in for the x's. You need to substitute a x plus 4. So in place of these 2 x's, I need to plug in this. So it's kind of 100% algebraic. Y equals x squared, whatever I plug in, squared, minus 1 plus 2 times whatever I plug in. Okay, now I'm plugging in, not a number, I'm plugging in algebra. X plus 4, x plus 4. This is tricky. X plus 4 squared is x plus 4 times itself, x plus 4, which is distributive. X times x is x squared, x times 4 is plus 4x, 4 times x is plus 4x, 4 times 4 is plus 16, then I got a minus 1, then I got to distribute this, plus 2x, 2 times 4, plus 8. So I'm going to add up all my x's. So I got an x squared, 4x, 4x, and 2x is 4, 8, 10, 10 x's. 16 minus 1 plus 8. So 16 minus 1 is 15. 15 plus 8 is 23. And there we go. That's it. I think that's it. So make sure you got good notes.